Hello students. So this is the revision sheet for electrical installation. I hope you're enjoying your holiday, but I really want you to spend some time in revising for your exam. So very quickly, the first few questions are very easy. What are the factors influencing severity of a shock, or the three-stage safety model? Recognize a hazard, evaluate, and then control. Different PPE, personal protective equipment, so you should know some from this list. These questions are very easy. If they come up in the exam, you should not make any mistake in this. Now, these red circles with the slash across them are prohibition signs. So you cannot wear a cap, for example, or do not turn off, or do not smoke, things like that. The yellow triangle is to show a hazard, a potential danger. These blue signs are mandatory. That means these actions have to be done. For example, this one, protective footwear must be worn, or ear protection must be worn. Safe condition. So what should happen if there is an emergency? What is the procedure that should take place? And these are for fire equipment. Please memorize these. Also memorize these types of screwdrivers. So the cross section, or what does the head look like? Maybe they will give you a picture of this and you have to draw these. So please memorize these. Very, very easy. Appropriate tools to be used. When should you use an Allen key? When should you use side cutters, pliers? When should you use wire crimpers? Very easy, please. You need to memorize these. Describe 3-pin fused plug socket. So we know there are 3 wires. The green and yellow is the earth wire. The brown one is the live. And the blue one is the neutral. So maybe if they give you a picture with the wires not drawn, you should be able to draw them and label them. So in this question, they want you to draw a lighting circuit diagram, one-way lighting circuit diagram. How do you begin? Now in a one-way lighting circuit diagram, what do we have? We have a switch and we have a lamp. So if you see, this drawing that I'm doing is very, very simple. We only have 2 components, a switch and a lamp. The switch always connects to line. The lamp goes into neutral, so the loop is complete. Now, because it's a circuit diagram for installation, we need some extra things. For example, the switch and the lamp must be enclosed inside a square like this, a dash dot type of square. So whatever components you have, put them inside squares like that. And the switch has an extra thing here, like a line like that, to show that it's a switch. And repeat this diagram for the lamp also. Dash, then a line, then a dot. Pardon my untidy drawing. Please do better than this in the exam. So that's it. This is a one-way lighting circuit. Easy. The next question asks you also again for a lighting circuit, but a using two-way switches. Now in a two-way switch circuit, first of all, when will we use it? When we have a long corridor or you have a staircase and you want to control one lamp from 2 switches. Now this might look confusing to you, but don't worry. Make the two-way switches. Before you do anything, make the two-way switches something like that. Identical, mirror image of each other. Now connect them. So let me use a different color to show you the connection. And then this gets connected to the lamp. And what happens to the lamp? The lamp goes into the neutral. The switches will always be connected to the line. Now tell me what's missing. What do we need? We need to put these components inside that dash dot type of square. Like that. And what else is missing? We are missing this for the switch, this line. So that's about it. You will do this and you'll repeat for this switch and you'll repeat for the lamp. So at the end you will get this. And for the switch, sorry, not nice. Like that. I hope it has made some sense. So start by drawing the switches facing each other, then connect them directly, and then the switches always go to line. Right, so identify factors affecting cable size calculation. Now, if you remember, we did this when we did the BTech assignment. So first you find the current. What is the load current going to be? That's called the design current. Or what are the external influences? Where is the circuit going to be? What is the protective device? That is called, the rating of the protective device is called IN, and so on. So please memorize these. Now let us solve a question. So for example, a single lighting circuit has a total power consumption of 2000 watts using 100 watt filament lamps. Calculate the design current. Now how do you find current? Current is power divided by voltage. So please memorize this formula. Power over voltage. So the power they have told us is 2000 watts. So 2000 divided by 230. Why 230? Because this is the voltage that we get at homes. So IB is 8.7 amperes. Now if the design current is 8, what should my fuse size be? So 8 is somewhere here. Yeah, so you always choose the next higher value. So the fuse should be 10 ampere. Right, in this question they're asking you for the factors that affect cable size calculation. Now if you remember, in the BTech assignment we had done a question where we had to find the current, and then we had to decide which MCB and which fuse will be appropriate for it. So what we had found, the current is called the design current, rating of the protective device IN, and correction factors CA, CI, CG, CC. We'll have a quick look at these also. So all these things affect the size of the cable that we should choose for our circuit. Please, you need to memorize these. Now, IB is the smallest current, and what is that? The design current. So if I know I will be using 5 lamps in the room, then I will know how much current will be flowing through the circuit. This current should be lower than the fuse. So let's say my current is 8 amperes. What is the next available fuse? Let's say it's 10. So IN is the current rating for the protection device. So the fuse size maybe. IZ is the current for which all the correction factors have been applied. And IT is the current rating of a cable in amperes. So this is the relation between them. IB, the design current, is the smallest. The fuse rating of the fuse should be bigger than that. Then the current with all the correction factors should be bigger, and the current that we get from the table should be the highest. So let's have a look at this question. In this question, they are saying the total power consumption is given to us. Now, in case they do not give you the power consumption, you will have to calculate it. If they say there are 5 lamps of 200 watts each, so 5 times 200 is 1000. 1000 watt is the total wattage for your circuit. So in this case, they've given you the total watt, 2000, and they're asking you to calculate IB. The formula that relates current with power is I equals P over V. Given over here, but I'll write it so you can see it very clear. I equals P over V. What is P? 2000. What is the voltage? Because it's a domestic lighting circuit, the voltage is 230. So 2000 over 230, the design current is 8.7. Now if I look at this table for the fuse size, where is my IB? The current is right here in the middle. That means the fuse that I will use should be 10 ampere. IB should be less than IN. So what's the next higher value? 10. So the fuse should be 10 ampere. Moving on. Now the 4 correction factors that you should know about are ambient temperature, thermal insulation, grouping of cables, and protection type. Basically, what is this? Once you've calculated the design current, even the temperature will also make a difference on what type of cable you should choose. How many cables will be together? All this has been predefined in the BS book, even in the ADDC manual that we saw. And this is the formula to calculate IZ. IN over CA times CI times CG times CC. What is IN? IN is the value of the rating of the fuse. Rating of fuse. So please, you need to memorize it. So now students, now we are at the radial circuit wiring. Now the diagram that they've shown, if it confuses you, please use the diagram that we had learnt in class. So basically you start by drawing the consumer unit, that you can draw by just a rectangle. In the consumer unit, you've got an MCB. This MCB is the line. So you take it to the first socket, from the second to the third, second to the third, third to the fourth, and fourth to the fifth, fifth to the sixth, and whatever. That's it. Now, what else is there? Then we have the neutral. So neutral starts from another part and it goes hops first, second, third, fourth, fifth, sixth, and done. The third one, now I don't have a green pen, I'll use this yellow. Oh, I can, oh sorry. Yeah. So the last one is the earth. So start from the consumer unit again, hop to the next one, hop to the next one, hop to the next one, next, and next. This is your radial circuit. What are the advantages of radial? Now this is the diagram that they've shown. If you find this simpler, please use this. The advantages of a radial circuit are faults can be easily located, and the disadvantages, if one of them breaks, this one stops working, then the others will also stop working. Now let's come to the ring diagram. The ring diagram, I think, this one is simpler, so let's use this. So you start with the line. The line goes to the first socket, from the first to the second, second to the third, third to the fourth, fifth, sixth, and whatever, and from the last one goes back. Similarly, the neutral travels to all the circuit, from the last one comes back, and the earth. So this way you have a ring. If this one stops working, all the others are still in the circuit, either from this side or from that side. So now the last part of this revision sheet is basically definitions, advantages and disadvantages. So what are the two types of overcurrents, overload or short circuit? How can you protect from them? You can use fuses or you can use MCBs. What is a cartridge fuse? So this is what a cartridge fuse looks like. It has a thin wire between the two ends, and that wire burns out when a big amount of current flows through it. What are the advantages and disadvantages of cartridge fuses? And how does an MCB work? Advantages and disadvantages of MCB. What is an RCBO? So RCBO is basically a combination of RCD and MCB. Remember, fuses and MCB do not protect humans. They will protect the circuit. They will trip when a huge amount of current flows through them. But if a person is getting shocked, then MCB and fuse will not be able to help. Instead, RCD is used for that purpose. So that's about it. Please, I really need you to revise very well, because all your marks for installation exam depend on this 100-mark paper. Good luck, and email me if you have any question. Okay, next question is, describe two types of contacts that can result in a person receiving an electrical shock. So the two types of contact are direct contact and indirect contact. So direct contact is, let's say there is a line that I touch. So if I poke my finger into the socket or I touch a live wire, that is direct contact. Indirect contact is when, let's say, there is a fault, and because of that fault the metal of my washing machine is conducting, and if I touch that, that is called indirect contact. Direct contact is protected by something called basic protection, and indirect contact is protected by fault protection. So what is basic protection? The first one is insulation. Insulation is a protection, and maybe there is a barrier or an enclosure, and maybe they have made a rail so I can't touch the circuit directly, or maybe the live parts are very high up so I can't touch them at all. These are all these are all basic protection, which is basically protection against direct contact. And so now the last part of this revision sheet is basically definitions, advantages and disadvantages. So what are the two types of overcurrents, overload or short circuit? How can you protect from them? You can use fuses or you can use MCBs. What is a cartridge fuse? So this is what a cartridge fuse looks like. It has a thin wire between the two ends, and that wire burns out when a big amount of current flows through it. What are the advantages and disadvantages of cartridge fuses? And how does an MCB work? Advantages and disadvantages of MCB. What is an RCBO? So RCBO is basically a combination of RCD and MCB. Remember, fuses and MCB do not protect humans. They will protect the circuit. They will trip when a huge amount of current flows through them. But if a person is getting shocked, then MCB and fuse will not be able to help. Instead, RCD is used for that purpose. So that's about it. Please, I really need you to revise very well, because all your marks for installation exam depend on this 100-mark paper. Good luck, and email me if you have any question.